Welcome to this first video in the series where we will be looking at geometry and various ways of quantifying. That means measuring different geometric shapes. And in this video, we will be looking at perimeter. By the end of this video, you should be able to do the following things. One, you should be able to calculate the perimeter of this triangle. Two, you should be able to calculate the perimeter of this regular pentagon, if I can draw one. If each of those sides was, let's say, 10 centimeters, you should be able to also find the missing side lengths of this square. So if I gave you the perimeter, P, you should be able to tell me what the side lengths are. And then if you could do that, you'd also be able to do, for example, find the perimeter, or not the perimeter, but the missing side lengths of this hexagon. So if I gave you the perimeter and said that that was 72 centimeters, you'd be able to go backwards and tell me what those missing side lengths would be. So if you can do all of that stuff confidently today, you could probably skip ahead and go to the next video in the series. But if you want to practice, review, and gain confidence in those skills, join me and we'll go over all of those things together. First of all, in the next few videos, if you're still with me, we're going to be looking at dimensions. Okay, so a dimension is like an extension in space. So let's look at a line, for example. So a line goes on forever in both directions, but only in one dimension. So it goes forward and back, but it has no thickness. I can't draw a line with no thickness. That would be impossible to do. But in mathematics, you can imagine one. So this does have a thickness, but a true one-dimensional line would only extend in one direction. If we took a piece of that line, though, and it had beginnings and end, we call this a line segment. So a line segment has a beginning and an end. If you can imagine a piece of string that had a beginning and an end, we could take that string and we could wrap it around something. So for example, if you had a square like so, you could take a piece of string and you could wrap it around that square. So that string, or that distance around the outside of the object or the shape, is the perimeter. So in perimeter, we're dealing with the outside measure of the side lengths of a shape. So when we measure perimeter, we do not concern ourselves with the inside of the shape. The only thing we're caring about is the outside, the distance around the outside of the shape. Now, an enclosed shape, like this, for example, if we're imagining this was a square, an enclosed shape like this is called a polygon. A polygon. Polygon comes from, the word polygon comes from two Latin words. The first one, poly, means many, and the other word is the Latin word gonos, which means angled. So a polygon really just means a many-angled shape. What we're going to be looking at in this video is how to measure the perimeter of what are called regular polygons. So regular polygons are special because they are polygons where the outside side lengths, or their side lengths, and their interior angles are all the same or congruent. Okay, so this square that I've attempted to draw has four sides that are the same. Let's pretend they were 5 centimeters long each. These little marks that I've drawn tell you that the sides with those marks on them are the same. Even if you've drawn it by hand and it doesn't look the same, that just says those lengths are the same. And these interior angles of 90 degrees are also all the same. So shapes that have these characteristics are called regular polygons. So there's a regular polygon, we call that one a square. Here's another regular polygon. And again, I'm drawing these freehand, so they're not mathematically precise, but that's what I can use these markings for. So this is a three-sided polygon with three sides that are the same. Let's again just imagine that they're 5 centimeters long. And the inside angles are all 60 degrees. And because all the angles and the sides are the same, it is a regular polygon. So you can imagine any number of irregular polygons. There's one with 3 sides, obviously tri meaning 3, and angle, 3 angles, triangle. You could have a regular polygon with 5 sides. Sorry, this is your pentagon. And again, these hash marks would say all those sides are the same length, and so on. So if all the sides and all the angles are the same, it's a regular polygon. Shapes that have different side lengths are called irregular polygons. And you could draw yourself an infinite number of those. So a rectangle is an example because its side lengths are not the same. This one and this one are the same, and this one and this one are the same, but all 4 are not identical. Here's another irregular polygon. It's just sort of a random construction I've made. The side lengths aren't the same. The angles are all different. So it again is not a regular polygon. You could have an irregular triangle, right? A triangle where the sides are not all identical. So those are basically your 2 kinds of polygons. You have regular and irregular polygons. Okay, in this video we're going to look at how to measure the perimeter of regular polygons. And because they're regular, we can think about how to use some of the things that we've used already this year when we've come up with expressions and equations to help us. So here is a square with the side lengths given. I'm going to tell you what its measurements are. So each side is going to be 9 centimeters long, and you know that they're all the same because of those hash marks. That means it's a regular polygon. It is a square. All 4 sides are the same. So to find its perimeter, I just have to remind myself that there are 4 sides. Each is 9 centimeters. So I could do that a couple of ways. I could go 9 plus 9 plus 9 plus 9. I could add those together to get 36 centimeters. Or I could think using multiplication and say 4 sides times 9 centimeters equals 36 centimeters, and therefore the perimeter, P, is 36 centimeters. Okay, so we've just calculated the perimeter of that square. We could also then go a step further and say, well, that means there's a rule for squares. And the rule or equation or expression that would describe the perimeter of a square would be 4 times the side length, L for example, we'll call L for length, equals perimeter. So for any square, if you know the side length, multiply it by 4, and you have the perimeter. So let's do another one. Here's a square. Make this one a little bit smaller. Let's say this is 2 centimeters on that side. Well, my rule is 4 times L, or 4L equals P. 4 sides, 2 centimeters, 4 times 2. So I could swap that 2 in. 4 times 2 equals 8 centimeters. So here's a nice handy little rule. For squares, it's 4 sides. 4 sides times the side length equals the perimeter. Let's do one more. Let's do one more. Here is another square. We know it's a square because of these marks telling us all four sides are the same. This time, let's make these sides 22 centimeters. So I know that it's 22 on all sides. 22 and 22 centimeters. So for the perimeter, I'm just adding all four sides, the distance around the outside of the shape. So it's 4 times 22 centimeters equals, and if you need to rewrite it, we can do it this way, is 88 centimeters. So the perimeter is equal to 88 centimeters. Okay, but not all regular polygons are squares, so let's look at another one. Let's look at a triangle, another basic shape. All three sides are the same. Let's give this one a side length of 25 centimeters. This is a big triangle. So what do we know about triangles? Triangles all have three sides. So just like the square had a rule, the triangle has a rule. It's going to be 3L equals P. This is just for regular polygons, right? Because we know that every side is the same. So we're going to multiply it by 3 to get our three side lengths. So if the side lengths are 25, it's 3 times 25 centimeters equals 75 centimeters. So the distance all the way around would be 75 centimeters. Okay, this is why measuring our regular polygons is handy, because we know that all the sides are the same, so we're simply multiplying by the number of sides. So here is an attempt at drawing a regular hexagon. All of its sides are the same. It has 6 sides. Let's give these side lengths a measure of 11 centimeters. There are 6 of them, all 11 centimeters. So we know that our rule is going to be 6 sides times 11 centimeters. You could probably do that one in your head. 6 times 11 is 66 centimeters. So our perimeter equals 66 centimeters. And again, that would follow for any pentagon, or sorry, any polygon that you could draw. If you could draw a 10-sided, I'm not going to try and draw a 10-sided or a decagon. It'd be too hard to draw freehand. But if you had a 10-sided shape that was a regular decagon, you'd know that it's 10 sides times the side length, and that would tell you the perimeter. So imagine we had a decagon that was 10 centimeters long on each side. We'd have 10 times the 10 centimeters would equal 100 centimeters. This is why I think you'll find that perimeter for regular polygons, once you've practiced it, is fairly straightforward. Now let's notice something here, that so far we've had shapes where we knew the side length and we wanted to know what is the perimeter. And so we used our rule, or we used our formulas, or we used addition to say that, well, 4 sides times 5 centimeters, the square would give us 20 centimeters. But we can also use the information we have to go in the opposite direction. So let's say I had a square and I didn't know what the side lengths were. These are a mystery. But I do know that the perimeter is, let's say, 48 centimeters. Okay. So before, if I had the side lengths, like I did over here, my rule was the number of sides. So for a square, it's 4 sides times the side lengths equals the perimeter. Here, I have the perimeter, but I don't have the side lengths. So this time I'm going in the opposite direction. I know this. I know it's 4 sides. So 4 sides times something equals 48. Or we could say, as we did earlier this year, 4L. Let's use our variable. So 4L equals 48. And just like before, we know that if we want to find out what the variable is, we can undo what's being done to the variable. So in this case, the variable L is being multiplied by 4. So to undo that, we do the opposite operation. We can divide by 4, but since it's an equation, we have to do the same thing on both sides. So we can divide by 4 here. And when we do that, we get rid of the 4, and we get L equals 12, or the side length equals 12 centimeters. So this is simply saying that if we have the perimeter and we don't have the side lengths, we can divide the perimeter by the number of sides, right? So here we had a square, so we're dividing the perimeter by 4. If we had a triangle and we didn't know the side lengths, these were mysterious, and the perimeter, let's say, was 33 centimeters. Well, there's 3 sides, so we could go perimeter divided by 3, divide the perimeter by the 3 sides, and that would tell us that the side lengths are 11 centimeters. So we can go in both directions. We can do what we did here, where we knew the side length, and we multiplied it by the sides to come up with the perimeter. Or we could do what we did here, and we could say we know the perimeter, and we could divide by the number of sides to get the side length. And of course, you can do that for any regular polygon. If I have a hexagon here, a 6-sided shape, I don't know what the side lengths are, but I know that the perimeter, let's say, is 36 centimeters. Okay, well, the total of all 6 sides is 36. So I need to divide this by the number of sides, which would tell me that the side lengths are 36 divided by 6, which is 6 centimeters. And again, since this is a regular polygon, all 6 sides are the same, and we've done it. Okay, so what we've practiced here is using the information that we have, which is either the side length to find the perimeter, or using the perimeter to find the side lengths. And we can think, because these are regular polygons and we know the number of sides, that it's really about knowing the shape that you're dealing with. So let's try a couple on your own. So try this one. Here's a square. I'm going to tell you the side length, and let's say it's 15 centimeters. So, using the rule, what is the perimeter? 4 sides, one of them is 15. Pause the video, work it out, and then come back and let's see what the answer is. Okay, well, you're back. So hopefully what you did was you said 4 sides times 15 centimeters equals 60 centimeters. I'm going to give you 3 like this to try on your own, and then we'll come back and talk about them. So, number 1, let's go triangle. Side lengths are, let's go 12 centimeters. What is the perimeter? Number 2. Let's do a hexagon. So 6-sided shape. 1, 2, oops. 1, 2, 3, 4, 5, 6. Now, they're all the same. I know it's not perfectly drawn, but each side is going to be 8 centimeters long. So what is the perimeter? And finally, number 3. This time you've got, let's go with let's do a pentagon, so a 5-sided shape with side lengths of 20 centimeters. The perimeter is what? Again, pause the video if you need to work those out. Okay, so let's talk about these. So with the first one, number 1, we had a triangle, so 3 sides. So the perimeter is equal to 3 times L, which means the perimeter is equal to 3 times 12, which means the perimeter is 36 centimeters. Okay, number 2, this is a hexagon we're looking at. So this is a 6-sided shape, so our rule would be it's 6 times the side lengths, which in this case is 6 times 8, which means that the perimeter is equal to 48 centimeters. And lastly here, we have a pentagon, a 5-sided shape, so our rule would be 5 times the side length, which in this case is 5 times 20, which means that our perimeter is equal to 100 centimeters. Okay, last set I want you to try. This time we're going to go the opposite direction. We are going to do a couple of shapes in which we don't know the side lengths. So these are a mystery, but we know the perimeter. And for this one, let's say that the perimeter is 88 centimeters. And for number 2, let's do a triangle where we don't know the side length, but we know that the perimeter is 225 centimeters. Very large triangle. And number 3, let's do a pentagon, a 5-sided shape, 1, 2, 3, 4, 5, where again we don't know the side lengths, but we know that the perimeter is 35 centimeters. Okay, pause the video, work those 3 out, and we'll come back and talk about it. Okay, so let's look at these. Here's our first one. It's a square. It has 4 sides, but we don't know the side length. We know the perimeter is 88 centimeters. So our rule is always going to be that we divide the perimeter by the number of sides. So in this case, it's perimeter divided by 4 will tell us the side length. So 88 divided by 4 equals 22 centimeters. So our side length is 22 centimeters. With this triangle, 3 sides, so it's our perimeter divided by 3. So I can go 225 divided by those 3 sides. Pardon me. So our total here is 75 centimeters, which means our side lengths are each 75 centimeters. 225 divided by 3 equals 75. And finally, we have our pentagon here. So it's a 5-sided shape. Our perimeter is 35, which means we're going to divide our perimeter by 5 sides, which is 35 centimeters divided by 5 to give us 7 centimeters. So our sides are each 7 centimeters. Okay, so that's how we can find the perimeter and measure the side lengths of regular polygons. At the beginning, we asked you if you could do these. By now, you should be able to. And if you are still feeling like you need some practice, please review what we did here and make sure to use the practice tools that have been provided for you. See you in the next video.